Okay, since that first explanation took a while, I decided to cut it into 2 videos. So let's go back onto the front page. And let's take a look at number 1, because that again looks a little bit more on the basic side because the denominators are pretty simple. So again, if we were going to add this, what would be our LCD? Okay, what would be our least common denominator? So that's kind of something you want to think about off to the side. If we wanted to add 5x plus 2x, we can't, okay? But what is the smallest expression that they both go into? That would be 10x, right? 10x goes, or 5x goes into 10x, 2x goes into 10x. So here we're going to multiply top and bottom by 2 over 2, which turns us into 6 over 10x, and it's fine to multiply those together. Over here, we're going to multiply by 5 over 5, which gives us 7 plus 5 is 35 over 10x. And if we want to do the same over here, we get 10x over 10x, right? So notice we have everything the same. You technically can cancel out your denominator now. If you'd rather add your 6 plus 35 now, you can. So it is written as one fraction equals another. Again, since those denominators are equal, really what we're doing is multiplying both sides by 10x. We're not going to show it. We're just going to get rid of it and say 41 equals 10x. Divide both sides by 10. And x equals 4.1. We have to make sure it works. Go back to your first one. If we were to graph this, what would be our vertical asymptote? X equals 0. If we were to look at the other one, 7 over 2x, what would be our vertical asymptote? X equals 0. Those would be the only breaks in our domain. Those would be the only values where either one of those are undefined. 4.1 is not 0, so this will work, okay? And you can check it by plugging it in, okay? Let's take a look at, why don't we do number 2? So here, you might be thinking, oh man, I can't figure out these what the common denominator is. But notice this one over here, the first one. If you were to factor that, notice it is the other denominators, right? So it's 2 factors of 12 that add up to -8 are -2 and -6. So it's kind of gearing us to know what our LCD should be, okay? So when you look at k over k minus 2, which factor is it missing? It's missing the k minus 6. Whatever you do to the bottom, you have to do to the top. So that gives us k times k minus 6 all over k minus 2 times k minus 6. Here, what are we missing? The factor of k minus 2. And remember what factors are. They're things that are multiplied together, right? So now notice, your denominators are the same. Once we do that, we can get rid of our denominators. If you want to add those fractions on the right first, go for it. If you don't, we'll do it now. So what you get is 4 equals, I am going to distribute this, k squared minus 6k plus k minus 2. Again, you have a quadratic, so we're going to set it equal to 0, combine our like terms, and we're going to factor. Oops, this is a k. What are our 2 factors of -6 that add up to -5? -6, positive 1. When we solve those, we get k equals 6 and -1. Again, we have to go back and check for our extraneous solutions. What are extraneous solutions? They're the domain errors. They're where the vertical asymptotes, if you were to graph these separately. What would be our vertical asymptote here? K equals 2. What would be our vertical asymptote here? K equals 6. What would be our vertical asymptote here? Both of them, right? So, do either of our answers match any of the places where we have vertical asymptotes? Answer is yes, 6. Okay, 6 cannot work. That is an extraneous solution. It's a solution that shows up, but when you check it in the problem, it does not work because it gives you a domain error, right? You can't divide by 0. So even if you plugged in 6, you would get an answer for this one, the k over k minus 2, but then you'd have plus undefined. That doesn't mean anything. Can't do anything with that. Okay? Okay, we'll look at question 3 here, and maybe this would be one where you can pause it and check back in. So how about this? How about, let's say, figure out your LCD, get your common denominator, and then unpause it and see if you match. Okay, so in the first fraction, you're going to multiply top and bottom by b plus 2 over b plus 2, and I wrote that in blue. For the minus 2, you're going to multiply, you have to do both, b plus 2 times b minus 2 because it doesn't have a denominator. And then in the last one, you're going to have to do b minus 2 over b minus 2, okay? So at this point, your denominator is the same, okay? So we technically are going to multiply both sides by that common denominator, which in the end just gets rid of it, okay? So your next step would be is to simplify your numerators, what you have left, and get and we're going to have a quadratic for sure, because you can see you're going to have to FOIL with the blue, you're going to have to FOIL with the red. So we're going to have some b squareds, so you're going to want to set this equal to 0. So pause this. I want you to simplify and set equal to 0. So when you simplify by FOILing the blue, b plus 2 times 2b minus 5, you get 2b squared minus b minus 10. When you FOIL b plus 2 times b minus 2, those are conjugate pairs, so you're left with b squared minus 4. You do have to distribute a negative 2 through. Don't forget that minus sign, because it is a minus 2, so it has to get distributed, and that's why it becomes negative 2b squared plus 8. And then the right side, you get 3b minus 6. So actually with this one, your b squareds cancel. So you're not going to have a quadratic. So what I would suggest doing is moving your b's to one side and your numbers to the other. So I'm going to add b, so that gives me 4b. And I'm going to add 6. And I'm going to combine the negative 10 plus 6 is negative 4 plus 8. Gives me a positive 4. And you get b equal to 1. Again, you have to check to make sure that is not an extraneous solution. Going back to the beginning, what would our vertical asymptote be of that first one? b equals 2. That is not 1, so it's okay so far. Next one doesn't have any restrictions on the domain. And then this one, your vertical asymptote would be b equals negative 2. So since 1 is not 2 or negative 2, it's not an extraneous solution, and it will work, okay? And you can check it by plugging it in. All right, the only one we haven't done besides the one that is worked out for you is the first one, okay? So I'm not going to go through this step by step with you. I would say figure out your LCD, and remember, when looking at your LCD, this is m minus 1. This is technically m minus 1 times m plus 1, and this is technically 1. What is the least common denominator that all three of those divide into evenly? M minus 1 times m plus 1. So you need to pause it, and I want you to try this entire problem on your own and come back and see if you get what I get. Okay, so your LCD is the m squared minus 1, so that was from here to here. And you guys, you have to show that you're multiplying by a factor of 1 right here and right here. You have to show that, because otherwise you're not explaining how you changed the problem and how it looked. So at this point, since the denominators are all the same, that's when we can get rid of that. And we do have a quadratic. So our two factors of negative 4 that add up to positive 3 are 4 and negative 1. And now you just have to check. What are the vertical asymptotes from the very beginning? What makes this undefined is when m equals 1. So you know that that can't be an answer. What makes this undefined? When m equals 1 or negative 1. And this doesn't. So your answer must be negative 4, and you can check it by plugging it in.